GNS Aluminum produces high-quality aluminum billets through an advanced manufacturing process. Raw aluminum is melted in high-tech furnaces, cast into billets, cooled, and heat-treated for strength. Strict quality checks ensure compliance with international standards before packaging and delivery, supporting sustainable and environmentally friendly production practices. The hot bending process involves heating a metal workpiece to a specific temperature to enhance its plasticity, making it easier to bend without cracking. The metal is then bent using specialized machinery, such as hydraulic presses or bending machines, to achieve the desired shape. After bending, the piece is cooled to set the shape, and further post-processing may be done, such as heat treatment, to ensure the metal retains its strength and integrity. Skilled operators oversee each step to ensure precision. The Drake Metal Scrap and Cars Shredder from Ing. Bonfilioli is designed to process various metal scraps, including automobile bodies. The process begins by feeding materials such as mixed scrap, bales, and car bodies into the shredder. The high-performance hammer mill operates automatically, ensuring efficient shredding with minimal manual intervention. The system's robust design minimizes energy consumption while offering low operational costs. Advanced features, such as durable Hardox steel hoppers, low-maintenance rotors, and efficient dust filtration, make this system highly efficient and environmentally friendly, ensuring optimal processing results in the recycling industry. The production of a saw blade involves a series of precise steps to ensure high efficiency, durability, and sharpness. The process begins with selecting high-quality raw materials, typically high-carbon steel or carbide, known for their toughness and wear resistance. The first step is cutting the material into blanks of the desired size. Next, the blade undergoes shaping and grinding to form the basic outline and initial structure. CNC machines are used to ensure precise measurements and smooth edges. Afterward, the teeth of the blade are created through a combination of advanced milling and grinding techniques. These machines are programmed to form the teeth, with exact specifications to ensure uniform cutting performance. The next stage involves heat treatment. The blade is heated to a high temperature and then rapidly cooled to harden it, enhancing its strength and resistance to wear. This process also ensures that the blade maintains its cutting ability over extended periods of use. After heat treatment, the blade is ground again to sharpen the teeth and remove any imperfections that may have developed during the heat treatment process. Once the blade is shaped and sharpened, it undergoes quality control checks. Technicians use advanced testing equipment to evaluate the blade's hardness, sharpness, and overall quality. Any blades that do not meet the required standards are discarded or reprocessed. Finally, the saw blades are coated with a protective layer to prevent rust and corrosion. After inspection, the blades are packaged and shipped to customers. This manufacturing process ensures that the saw blades are efficient, durable, and capable of delivering consistent performance. MMG 5D Technologies' production process combines traditional casting with advanced machining. Their large copper alloy melting plant and 5-axis CNC mills ensure precision. Quality control is maintained with high-precision measuring and integrated management systems. Meyer-Werft builds the spectrum of the seas through an advanced production process. The process includes detailed design, modular manufacturing, assembly, interior decoration, and equipment installation. Modules are produced in separate workshops and then assembled. Quality checks, including sea trials, ensure operational stability and safety. Modern technology and skilled craftsmanship combine to create luxury cruise ships like Spectrum of the Seas. Forged arc welding (SAW) is a welding method used for pressure vessels, providing strong, high-quality welds with deep penetration and minimal spatter. It's ideal for thick-walled vessels and industries. The permanent mold casting process for aluminum alloy wheels begins with the preparation of a metal mold with the exact wheel shape. The aluminum alloy is melted at 650 to 750 degrees Celsius and then poured into the mold. Once the aluminum has cooled and hardened, the mold is removed, and the wheel is machined to the required size and shape. The steelmaking process begins with melting scrap and alloys in an electric arc furnace, EAF, followed by refining in a ladle furnace to eliminate gases and fine-tune the chemical composition, producing high-quality molten steel. Next, the ingot casting stage involves pouring the molten steel into molds, where it solidifies into ingots with a uniform structure, achieved through precise casting methods. The forging step then takes over, heating the ingots to 1100 to 1250 degrees Celsius and shaping them using powerful hydraulic presses or forging hammers into robust rough forms, such as crankshafts or turbine shafts. This is followed by billet machining, which includes rough machining to remove excess material and finish machining on CNC machines for exact dimensions and smooth surfaces. Finally, the pattern making and mold casting process creates intricate steel parts by crafting patterns from wood or plastic, forming sand molds, pouring molten steel, and finishing the castings with grinding and shot blasting. Each step is meticulously designed to transform raw materials into durable, precise steel products, emphasizing the technical flow over any specific company context. The assembly of the Trent XWB, the world's most efficient aero engine developed by Rolls-Royce, is a complex process that combines precision engineering and advanced technology to ensure optimum performance and reliability. The air compressors are assembled with mid-pressure and high-pressure compressors with 8 and 6 compression stages respectively, increasing air pressure up to 50 times above atmospheric pressure, thereby optimizing performance and fuel economy. The compressed air is then fed into the combustion chamber, where fuel is mixed and burned at extremely high temperatures using lean burn technology to minimize NOx emissions. The combustion chamber components are protected by a heat-resistant ceramic coating. The next stage is the assembly of the turbine components, including the high-pressure turbine, with blades made from a single crystal alloy, and the low-pressure turbine that converts thermal energy into rotational force for the fan and compressor. The process begins with the fan module, where the approximately 3-meter wide fan blades are made from a carbon titanium alloy, along with a lightweight composite fan casing, before the blades are attached to the fan disc and connected to the low-pressure shaft, generating approximately 85% of the overall thrust. Finally, the entire engine undergoes rigorous performance, temperature, and durability tests before being integrated into the aircraft. This complex process, combining advanced technology and human expertise, underlines the unprecedented efficiency of the Trent XWB, achieving a 25% fuel saving that confirms the Trent XWB's leading position in the global aviation industry. ALPSAN Aluminium's production process is a blend of cutting-edge technology and quality control, ensuring the highest standards in aluminum profile manufacturing. The process begins with extrusion, using 3 automated production lines capable of producing profiles with diameters of 4, 6, and 7 inches, and wall thicknesses as low as 0.7 millimeters. Their anodizing department, certified by QA Leonard, offers a range of finishes, including natural, gold, brown, and black anodizing in various shades, with environmentally friendly systems ensuring zero pollution. The company's vertical painting facility, established with second-generation technology, can paint profiles up to 7.5 meters long, ensuring a smooth, wire-mark-free finish. The use of 5-axis CNC machines enables precise machining of surfaces, ensuring customized solutions for high-volume production. Additionally, ALP-SAN uses a comprehensive assembly and packaging process to prepare products for sale. Complex thread turning is a high-precision machining process, crucial in aerospace, automotive, and oil and gas industries. Using CNC lathes and specialized tools, this process ensures durability and accuracy. The process starts with selecting materials like alloy steel, titanium, or aluminum. The workpiece is secured in a lathe, and the threading tool follows a precise helical path to form external or internal threads with the correct pitch and diameter. Advanced CNC technology and CAM software optimize tool paths, reduce errors, and improve efficiency. Hard thread turning enhances strength and longevity, making it ideal for demanding applications. The production process of Komatsu machinery at its Japanese factories is a highly organized and precise operation, reflecting the company's commitment to quality and innovation. It begins with mounting the track roller, swing circle, final drive, and idler, forming the undercarriage's foundation. The swing circle is then greased and mounted, followed by the crawler installation, ensuring mobility. On the main assembly line, the revolving frames are constructed, serving as the structural backbone. Key components like the main valves and hydraulic oil tank are mounted next, integrating the hydraulic system critical for operation. The engine, the heart of the machine, is then installed, followed by the attachment of exterior parts for protection and aesthetics. The process continues with docking, where the swing machinery, boom, and arm are mounted, enabling movement and functionality. The counterweight is attached for stability, and the bucket is fitted for digging tasks. Throughout, research and development ensure cutting-edge design. The final stages involve rigorous mechanical performance inspections and factory shipment checks to guarantee reliability. Once approved, the machinery undergoes factory shipment and delivery, ready to serve industries worldwide with Komatsu's renowned durability and efficiency. At MPJ Group, the production of high-quality aluminum and brass components for motors follows a well-defined process. It begins with advanced R&D software simulations, optimizing product designs before moving to the forging stage. The company uses 15 high-capacity presses with up to 4,000 tons of force to forge aluminum and brass alloys. After forging, the parts undergo heat treatment in specialized furnaces, where internal T4 and T6 treatments are performed under CQI-9 certification standards to enhance mechanical properties. The components are then processed through 17 machining lines, ensuring precision. Following machining, semi-automatic assembly lines are used for consistency and durability. Each part undergoes a thorough aesthetic inspection and finishing to meet high-quality standards. Finally, the finished products are stored in a warehouse before being shipped to customers, as required. Oscock Hydraulic Transfer Pressy is an automatic 4-station transfer press with a 2-magazine pulley loading system designed for efficient and high-quality production processes. This advanced machine is utilized in the manufacturing of kettles, offering exceptional precision and speed in the production process. The hydraulic transfer press works by transferring materials between stations, where each station performs specific tasks such as forming, shaping, and assembly. The automatic loading system ensures that materials are efficiently placed into the press for optimal results. With its innovative design, the Oscock transfer press significantly enhances productivity and reduces operational costs. Infit Team MS, located in the UK, offers a full bespoke electronic manufacturing service, covering design, production, testing, assembly, and fulfillment. They provide expert PCB assembly, testing, and turnkey manufacturing solutions, with a focus on various industries such as automotive, security, medical, and oil and gas. Their facility includes advanced technologies for surface mount and manual assembly, along with testing capabilities for high voltage, optical inspection, and extreme environmental conditions. Infit Team MS is ISO 9001-2008. The manufacturing process of NBC bearings, one of the largest bearing manufacturers in India, involves a series of sophisticated and efficient steps designed to produce high-quality bearings for various industries across the globe. Grinding technology from Isumi, Japan, and advanced methods from Italy and Sweden. The process begins with precision technology to produce nearly 100 million bearings per year in over 1,000 different sizes. The manufacturing facilities incorporate state-of-the-art machinery to ensure product performance and consistency. NBC Bearings serves various industries, including automotive, railways, steel mills, and heavy engineering plants. The company focuses on product testing, superior application engineering, and R&D to continuously improve product quality. Bearings undergo rigorous testing to ensure they meet the highest standards of precision, durability, and performance. NBC is committed to providing flexible, cost-effective, and reliable solutions, ensuring customer satisfaction and a strong global presence in 21 countries. The RG5Z 950E, part of the Titan 950 series, is one of the most powerful stationary twin-shaft shredders from ARJ, delivering maximum efficiency for the most demanding shredding applications. The machine is available in two versions, equipped with either a 250 kilowatts electric motor or a 405 kilowatts diesel engine, optimizing throughput speed and ensuring efficient material processing. With a specially reinforced hopper, the RGES-VZ 950E can easily withstand heavy loads, making it particularly suitable for shredding cars, light scrap, engine blocks, and aluminum. Its performance is impressive. For car bodies, the processing capacity ranges from 12 to 25 tons per hour. For white goods, it reaches 20 to 40 tons per hour, while engine blocks and aluminum can be processed at 15 to 30 tons per hour. Thanks to its robust design, high power, and exceptional versatility, the ARGES-VZ 950E is an ideal choice for the recycling industry, optimizing material processing workflows and enhancing overall productivity. The removal of the rotor from a 120,000 lb generator at Koffler required meticulous planning and coordination due to the massive weight of the equipment. Delivered on a 9-axle truck trailer, the generator's weight necessitated a separate driver for the trailer's tail end. To unload the generator, the rotor had to be removed from the stator, while the generator was still on the truck. The REPKON hot spinning machine uses the process of hot spinning, where a metal piece is spun on a lathe while a torch applies high heat to the workpiece. As the metal is heated, the tool on the lathe presses against its surface, causing it to distort as it spins. This process allows parts to be shaped or necked down to a smaller diameter with minimal force, creating a seamless shoulder. The hot spinning machine is particularly useful for bottom closing operations and neck forming operations, providing precision and efficiency in manufacturing. This technique ensures the production of parts with a high degree of accuracy and minimal material waste. The production process for high-quality steel cylinders, particularly for gas storage, involves several meticulous stages. The process begins with chrome molybdenum steel billets, which are heated in an electric induction furnace. The hot billets are then shaped into semi-finished products, known as pots, using a large extrusion press. These pots are lengthened to the required dimensions using a horizontal press. A forming machine is employed to close the neck of the cylinder, giving it its final shape. Once formed, each cylinder undergoes heat treatment in an annealing furnace to achieve the desired mechanical properties. Rigorous quality checks follow, including ultrasound testing for material integrity, strength measurements, and pressure tests, ensuring no defective products leave the production line. The final step involves surface preparation, where the cylinder's color is chosen based on technical standards and customer preferences. The cylinders are then shipped to customers worldwide. The production process of copper anodes at the horn smelter begins with the receipt of over 740,000 tons of copper-bearing concentrates each year. These concentrates, containing 10 to 40% copper, are delivered in powder form and undergo precise sampling techniques to ensure the quality and integrity of the materials. The smelting process begins by feeding these materials into the Noranda reactor, where they are heated to 1,200 degrees Celsius to liquefy. Oxygen is injected to bind sulfur and iron, and the resulting slag and matte are separated. The matte, containing 70% copper, is further refined in the Noranda converter to 98% copper content. The copper then undergoes additional purification in the desulfurization vessel at 1,200 degrees Celsius, removing sulfur traces. The final product, 99.1% pure copper, is cast into solidified anodes, which are cooled with water. These anodes, containing valuable metals like gold, silver, platinum, and palladium, are sent to a refinery for final refining into 99.9% pure copper cathodes. This copper is sold on global markets, while byproducts such as sulfuric acid are produced for various industries. The process demonstrates both efficiency and environmental responsibility, making a significant contribution to sustainable metal recycling. The process of manufacturing the Saarinen oval base begins by heating the aluminum in a furnace until it reaches a high temperature and becomes molten. The molten aluminum is then poured into a prepared mold, which is designed to create the exact shape of the base. As the aluminum fills the mold, the cooling process begins, allowing the product to take form. Finally, the product undergoes machining and finishing to ensure precision and high quality. Rotor winding is the process of winding the wire onto the rotor of an electric motor. In this process, copper or aluminum wire is precisely wound onto the rotor core to create the electromagnetic field necessary for the motor to operate. The process includes the steps of rotor core preparation, winding, insulation, and quality control. This is an important step to ensure the performance and durability of the motor, helping the motor operate stably and efficiently in industrial applications. The DN450 ball valve body machining process begins with placing the valve body on the machining machine and tightening the screws to firmly fix the valve body, ensuring that it does not move during the machining process. After the valve body has been fixed, the machine will rotate, and the cutter is inserted to process the valve body's edge. The purpose of this step is to create precise cuts, allowing the body to achieve a complete shape and meet technical requirements. The entire process requires high precision to ensure the quality of the final product. At any scrap car, The process of handling scrap cars follows a meticulous procedure designed to maximize recycling and minimize environmental impact. Vehicles are collected from various sources, including private car owners, auto repair shops, and fleet operators, with the company offering free towing services for easy transportation to their facility. Upon arrival, each vehicle is thoroughly inspected to identify valuable, reusable parts such as tires, windows, engines, and batteries, which are removed for resale or further processing. The car is then moved to a designated area where tires are removed, and the vehicle is fed into an industrial shredder. This machine reduces the car's size, allowing the metals to be separated by type, such as steel, aluminum, and copper, using advanced sorting technologies. Hazardous materials, including oils and fluids, are carefully removed and disposed of safely, ensuring compliance with environmental regulations. Finally, non-recyclable materials are sent to landfills, and the recycled metals are sent to specialized plants for further use. This comprehensive process ensures efficient recycling, safe disposal, and a reduced environmental footprint. The production of industrial boilers at Kubus Boilersan involves several key stages to ensure high quality, efficient, and safe operation. It begins with design and engineering, where engineers calculate key parameters such as capacity, pressure, and fuel type to ensure compliance with industry standards. Next is material preparation, where high-quality heat-resistant steel is selected, inspected, and cut into precise shapes. During fabrication and assembly, steel plates and pipes are cut, bent, and welded to form the main body and components, with precision welding ensuring structural integrity under high pressure. The installation of piping and accessories follows, integrating heat exchange tubes, combustion chambers, safety valves, and control systems. Rigorous testing and quality control are conducted, including pressure and leakage tests, to ensure durability and performance. Finally, in the finishing and coating stage, anti-corrosion coatings are applied to enhance longevity before the final delivery. This meticulous process guarantees reliable, high-performance industrial boilers suited for various applications. The leaf spring load tester measures load capacity and durability, using precise sensors and automated controls. The M200 mill turn, developed by WFL Mill Turn Technologies, is an advanced multifunctional turning, boring, and milling center, designed for machining large and complex workpieces. This high-performance machine is capable of handling components up to 2 meters in diameter, 14 meters in length, and weighing up to 60 tons. Its innovative design integrates established mill turn assemblies with a newly developed machine bed concept, ensuring exceptional precision and stability. The production process begins with high-quality raw materials, which are machined and assembled with strict quality control measures. The machine bed is constructed for maximum rigidity, reducing vibrations during operations. The M200 features ultra-high-pressure coolant systems, reaching up to 350 bars, ensuring efficient chip removal and extended tool life. It also includes a disc-type tool magazine with a capacity of up to 90 tools, allowing seamless tool changes at any Z-axis position. The heavy boring bar magazine supports large-diameter boring tools, making deep-hole drilling highly efficient. Its advanced automation enables turning, milling, and drilling operations in a single setup, minimizing downtime and eliminating the need for multiple machines. Operators utilize an intuitive control interface to program machining sequences with precision. Thanks to its robust construction and cutting-edge capabilities, the M200 mill turn is ideal for industries requiring high-precision machining of large workpieces, such as aerospace, energy, and heavy machinery manufacturing. The production of the Boeing 737 MAX involves a complex multi-step process that integrates human labor, advanced machinery, and automated systems. The process begins with design and prototype development, followed by the production of parts at specialized facilities worldwide. Key components such as the fuselage, wings, and tail are manufactured and transported to the final assembly line at Boeing's Renton, Washington facility. Here, workers and robotic systems collaborate to assemble the aircraft, combining structural components with electrical systems and interior fittings. Rigorous quality checks are conducted throughout the process, ensuring the aircraft meets safety and performance standards. Additionally, automation, such as robotic drilling and assembly lines, enhances precision and efficiency. Once assembled, the plane undergoes detailed testing. Before being delivered to airlines, Boeing continually improves its production process, ensuring high-quality output. The 3D 6-axis robot laser cutting machine is designed for metal sheet and tube cutting, offering high precision and versatility. The production process begins with designing the machine's mechanical structure using CAD software, followed by the fabrication of components such as the robot arm, metal frame, and laser optics. Once assembled, the system is equipped with a fiber or CO2 laser, depending on the material. The machine's robot arm, capable of 360-degree rotation, is programmed using specialized software to perform cutting tasks. This setup allows for both thin and thick metal sheet cutting and special-shaped tube cutting. The system simulates cuts before actual processing to ensure accuracy, optimizing the cutting process for metalworking industries. The production of 9mm ammunition follows a detailed process combining human precision with advanced machinery. It begins with the creation of brass cases, where metal discs are drawn into cylindrical shapes using hydraulic presses. The cases are cleaned and annealed to enhance their flexibility. Next, primers are produced by mixing chemical compounds, filling small metal cups with the primer material. Meanwhile, lead cores are cast and copper jackets are formed and cut. The bullets are assembled by inserting the lead core into the jacket, then swaging them into the final shape. During cartridge assembly, bullets are seated into the cases, primers are added, and each case is filled with smokeless powder. The final step involves crimping the case mouth and conducting rigorous quality checks before packaging. Automation ensures consistent production, while skilled technicians oversee the entire process for safety and accuracy. The production of a 32-ton load-bearing heavy horizontal lathe for large crankshaft processing involves several stages. First, components are designed using CAD and precision machined through casting or forging. The lathe is assembled, integrated with a CNC control system, and tested for accuracy. The machine's operation is calibrated, ensuring it can handle high loads and provide precise crankshaft processing. A CNC double-column vertical lathe is engineered for the precision machining of large, heavy workpieces. Its structure features two robust columns, supporting a cross rail equipped with a tool turret, while a sizable rotary table holds the workpiece securely. This design facilitates various operations such as turning, milling, drilling, and grinding. The vertical orientation allows gravity to aid in stabilizing the workpiece, enhancing machining accuracy. Additionally, the machine's modular configuration enables customization to meet specific manufacturing requirements. At MAN Energy Solutions, CNC machining processes are optimized using VeriCut simulation. This software detects potential collisions, reducing errors and setup time. By implementing VeriCut, setup time decreased from 8 to 2 hours, enhancing efficiency and preventing costly machine damage. The crankshaft exchange on the MS Zaandam cruise ship is a highly precise process. It starts with setting reference points to maintain the original engine position. Jacking brackets, specifically designed for this engine type, are installed to facilitate lifting. Lifting brackets are then used to raise and lower the crankshaft. System tests are conducted using 60-ton jacks and electrical hydraulic power units, HPUs. The new crankshaft, weighing 7.5 tons, arrives from Montevideo, Uruguay, and is brought aboard through the maintenance hatch. The engine block is jacked up to remove the old crankshaft, which is sent for refurbishment. The new crankshaft is carefully skidded into place, and the engine block is jacked down to minimize displacement. Finally, alignment brackets are installed, ensuring proper operation. The production of green pin shackles follows a precise process to ensure durability and safety. It begins with cutting high-grade steel bars to the required lengths. The steel is then heated, and undergoes forging, shaping the shackle body through upset forging, which strengthens the material. After forging, the shackle is bent into its final shape and cooled under controlled conditions to relieve stress. Meanwhile, the shackle pin is forged separately. Both components are machined to exact specifications, ensuring a perfect fit. Surface treatments like galvanization enhance corrosion resistance. During assembly, the shackle body and pin are precisely aligned and fitted together. Advanced, automated systems and strict quality control procedures ensure consistent performance and compliance with safety standards. This meticulous process guarantees green pin shackles are strong, reliable, and suitable for heavy lifting applications. The production of aluminum complex at Ras Al Khair begins with bauxite extraction at the Al Bayatha mine, followed by transportation to the alumina refinery. The alumina is then processed into aluminum at the smelting plant, which has a capacity of 740,000 tons annually. Next, the aluminum is rolled into sheets at the rolling mill. The complex also features a recycling unit with a capacity of 120,000 tons per year, ensuring sustainability throughout the entire production chain. The production of anchor chains involves forging steel into links, followed by heat treatment for strength. The links are welded together, tested for durability, and then coated for corrosion resistance, ensuring reliable performance in maritime environments. The production process at Metaltech begins with charging scrap steel into an arc furnace, where intense electric arcs generate heat, melting the steel. The molten steel is then refined by adding agents to remove impurities. For further refinement, argon-oxygen decarburization (AOD) is used, where oxygen and argon gases are injected to reduce carbon content and improve steel properties. This method ensures high-quality steel production with precise chemical composition for demanding applications. Brass manufacturing for the heating and plumbing industry begins with melting copper and zinc in precise proportions to form the brass alloy. The molten brass is then cast into molds to create billets or bars. These billets are mechanically processed using machinery to shape them into specific products like plumbing fittings or heating components. The surfaces are cleaned and treated to ensure resistance to corrosion and durability in high temperature and water environments. Quality control checks are performed to ensure each product meets the required specifications before packaging and distribution, ensuring reliability for heating and plumbing systems. The Carbide Inclined Bed Circular Sawing Machine KSS 1600 is designed for high-performance cutting of billets and tubes in various industries, including steel mills and railway wheel production. The machine uses a unique three-point clamping system, ensuring firm clamping even for warped materials. With a 45 degrees inclined bed structure, the machine directs cutting forces downward, reducing stress on the machine and enhancing durability. The circular saw operates with carbide cutting blades, making it efficient for both large and small cutting tasks. The sawing system is integrated into the production line, where billets are loaded into the machine and cut with precision. This technology allows for optimized cutting quality and speed while maintaining a consistent, high throughput, contributing to overall manufacturing efficiency in industries requiring precise cutting operations. The machine is an essential part of sawing plants for heavy-duty applications. CATL's advanced automation production line utilizes cutting-edge technologies such as AI, 5G, and machine learning to achieve high efficiency. The production process includes automated assembly and inspection systems, ensuring each battery cell is produced quickly and precisely. The use of robotics and real-time data analysis optimizes the production flow, allowing CATL to manufacture one cell per second, meeting the growing demand for electric vehicle batteries. The CDRA 500 hydraulic press, developed by Zetas, is designed to efficiently produce railway wheel sets using cold pressing technology. It operates without guide bushings and incorporates axle turning. The machine can press parts between the wheels and also allows for pressing off and checking of fittings. It features a horizontal design with columnar construction. The press cylinder, housed in the stationary crossbeam, applies force to the components against the bearing crossbeam. The crossbeam moves along threaded anchors with preset measured positions. The supporting crossbeam uses hydraulic wheel centering, while the rear crossbeam is equipped with hydraulic axle centering. The control system manages the press operation, monitors diagnostics, and detects errors. This system ensures precise adjustments, improving the overall manufacturing quality of railway wheel sets. The process is highly automated, making it efficient and effective in producing high-quality railway components. The high-trax traction motor armature rewind process at Houghton International follows a meticulous series of steps to ensure high-quality motor rewinds. The process begins with inserting insulation into the armature before the coil insertion. The coils are carefully inserted, with the coil ends positioned into the new commutator. A dial indicator is used to ensure the armature is running smoothly. The initial skim of the commutator is performed, followed by laser-guided precision cutting to ensure accuracy in shaping. A final skim of the commutator is done, followed by mechanical checks to verify the quality of the rewinding process. Data logging is utilized throughout the process for precise monitoring and analysis. The armature is then placed in a balancing setup, where it is rotated to achieve balance results. Once the specified balance tolerance is achieved, the balancing process is completed. A final balancing report is generated to document the successful completion of the rewind, ensuring the armature is in optimal condition for use in traction motors. The production of the dry-cutting bevel gear M5.5Z22 follows a detailed, precision-driven process. Initially, the gear's design is created using advanced CAD software, focusing on critical parameters like module size and the number of teeth. High-strength steel is selected for its durability and wear resistance. The next step involves dry cutting, a method that eliminates the need for cutting fluids, promoting eco-friendly and efficient production. Using CNC-controlled bevel gear cutters, the gears are precisely shaped according to the design specifications. After cutting, the gears undergo rigorous dimensional checks to ensure proper geometry, such as tooth angle and diameter, using precision measurement tools. Final stages include surface finishing, like grinding and polishing, to improve smoothness and minimize friction. The gears are then assembled and tested to ensure they perform seamlessly in mechanical systems, with quality reports confirming their compliance with industry standards. The entire process ensures high precision, durability, and performance. The machining process of a gearbox housing at Vulcan Industrial Eng involves CNC machining centers for precision cutting, drilling, and milling. Automated systems ensure accuracy, while quality checks maintain tolerances. Final finishing and inspections guarantee high-performance gearbox housings. CNC Technik Heil GmbH specializes in high-precision machining using the advanced DMG Mori DMU95 monoblock, a state-of-the-art 5-axis milling machine designed to handle complex geometries with extreme accuracy. The production process begins with engineers analyzing CAD models and technical drawings to develop an optimal machining strategy. Using CAM software, they generate precise tool paths that maximize efficiency and minimize material waste. Once finalized, the program is transferred to the DMU95 monoblock for execution. Before machining, operators prepare the workspace by securing the raw material onto the machine's large work table, which features a generous work envelope of 950 by 850 by 650 millimeters, allowing for intricate and large-scale component machining. Cutting tools are carefully selected and loaded into the automatic tool changer, ensuring smooth transitions between various milling operations. During machining, the DMU95 monoblock utilizes simultaneous 5-axis movements, allowing for the creation of complex surfaces in a single setup without requiring repositioning. This advanced capability enhances precision while reducing machining time and improving overall efficiency. The machine's high-speed spindle, robust structural design, and integrated coolant system contribute to optimal cutting conditions, ensuring excellent surface quality and extended tool life. Once machining is complete, components undergo rigorous quality control using coordinate measuring machines, CMMs, and other precision instruments to verify dimensional accuracy and compliance with design specifications. Additional post-processing steps, such as deburring, polishing, or heat treatment, may be applied to enhance durability and surface finish. After passing quality inspections, finished parts are cleaned, coated with corrosion-resistant materials, and carefully packaged for safe transportation. By integrating cutting-edge 5-axis milling technology with a highly efficient production workflow and strict quality control measures, CNC Technik Heil GmbH ensures the delivery of high-performance, precision-engineered components suitable for demanding industrial applications. Fusion Marine manufactures fish farms using HDPE, high-density polyethylene, a durable and corrosion-resistant material ideal for marine environments. The production process begins with designing cage structures using CAD software, followed by cutting HDPE pipes to precise sizes. Thermal welding techniques, including extrusion welding, ensure strong and seamless joints. Flotation devices are securely attached to maintain stability. Each structure undergoes rigorous quality checks, including pressure and structural integrity tests. Once approved, the cages are transported and assembled on site, where they are anchored securely. This process ensures high-quality, long-lasting fish farming systems suitable for various aquaculture applications. The toroidal field, TF coil production for ITER, involves multiple precise steps. First, niobium tin superconducting wires are fabricated and twisted into cables. These are heat-treated at 650 degrees Celsius to activate superconductivity. After bending into a double pancake shape, they are insulated, impregnated with epoxy, assembled into radial plates, and rigorously tested before final installation. The production of Doosan Skoda power steam turbines involves precision engineering and advanced machinery. The process includes CAD design, CNC machining of turbine blades, rotor stator assembly, dynamic balancing, rigorous testing, surface treatment, and final installation at power plants for efficient energy generation. At Giant's state-of-the-art factory in Tachia, Taiwan, the journey of a bicycle begins with precision and craftsmanship. The process begins in the loom room, where raw carbon fiber threads are woven into composite sheets. This foundational step ensures high strength and durability, forming the core structure of Giant's advanced bicycle frames. Next, the materials move into the layup room, where precision is key. Over 500 individual composite swatches are diligently cut, ordered, and carefully layered to create what's called a soft frame. Each piece is placed in a precise orientation to optimize stiffness and weight distribution, ensuring that every bike delivers top-tier performance. The preformed frame then enters the molding stage, a critical process where the composite layers are placed inside a steel mold and subjected to extreme heat and pressure in an industrial oven. This process solidifies the carbon fiber into its final form, ensuring structural integrity while maintaining an incredibly lightweight build. Once molded, the frame undergoes extensive finishing and painting. Skilled technicians carefully hand sand the surface, eliminating any imperfections and preparing it for a smooth, flawless paint application. Next, each frame is painted according to Giant's signature color schemes, then decorated with decals and logos, before receiving a final clear coat for protection. Quality control is at the heart of Giant's manufacturing. Every frame is subjected to 14 individual quality control inspections, testing for alignment, strength, and finish. Only after passing these rigorous checks does the frame move forward in production. Finally, after 9 hours of precision craftsmanship and 32 pairs of skilled hands, a high-performance TCR Advanced SL is born. The result is a thoroughly engineered bicycle, designed for both professional cyclists and passionate riders, ready to deliver speed, precision, and innovation to cyclists worldwide. With its combination of lightweight construction, aerodynamic design, and cutting-edge materials, every giant bike stands as a testament to performance and innovation. It begins with giant rolls of aluminum being fed into the assembly line, where they are stamped into parts like doors, hoods, and frames. Next, computer-controlled robots weld these parts together to form the car's structure. The cars are then hand-polished and moved to the paint shop, where robots precisely spray paint to create a glossy finish. Drive units are installed, and each car is tested on a dynamometer to ensure performance. Finally, the cars are tested on a test track outside the factory before they are ready for delivery. Easton Cycling, known for its expertise in carbon wheel production, follows a detailed, hands-on process to ensure the highest quality. Contrary to the belief that carbon wheel manufacturing is automated, Easton's method is highly manual and takes approximately 7 hours for each wheel from start to finish. The process begins with pre-preg carbon composite sheets, which are pre-mixed with resin and come in unidirectional fiber or woven patterns. These sheets are cut into specific pieces using a vacuum system at the Easton cutting table, guided by computer programs for precision. The cut carbon pieces are then transferred to the layup tables, where the rim structure is built. One side of the rim, male side, is formed using an aluminum core, while the opposite side, female side, is prepared. The carbon laminate pieces are layered on top of a latex-coated core to ensure proper compaction and avoid any fiber movement during the pressing process. Once the preform is complete, it's placed in a freezer, and after the latex shrinks, the preform is removed. The next step involves attaching the bladder and joining the two halves of the rim. The final carbon layers are applied to complete the preform. At this stage, plastic protection is removed, and the preform is weighed and logged for quality control. The preform is then placed in a press, where air pressure is applied to mold the carbon layers into shape. The mold is carefully cleaned to avoid contamination, and temperature measurements are taken to ensure consistent resin flow. Once molded, the rim undergoes a drilling process for the spoke and nipple holes, followed by a wet sanding step to prepare it for decals. The decals are applied using a water transfer process, and then baked onto the rim for durability. Finally, the rim undergoes a rigorous quality control process, where it's inspected for cosmetic defects, checked for alignment, and measured for spoke tension. If it passes, the wheel is packaged and shipped to customers, including professional cyclists like Cadel Evans and BMC Racing. Easton's meticulous process ensures that every wheel delivers both performance and quality, meeting the demands of cyclists worldwide. The production of a Pelton runner for small hydropower plants involves advanced engineering and precision manufacturing. As a global leader in hydropower technology, the company follows a sustainable approach with ISO 9001-2008 certification. The process begins with 3D design using CAT systems in collaboration with R&D teams. The Pelton runner is machined from a high-quality stainless steel monoblock on a 5-axis CNC machining center. After rough milling, the runner undergoes fine milling, grinding, polishing, and balancing, ensuring maximum efficiency. With over 400 hours of machining, the Pelton turbine is then pre-assembled and rigorously tested for quality and performance. Buddy Bar's Aluminum Sand Casting and Machine Shop specialize in producing complex, high-precision aluminum sand castings that meet stringent customer requirements. We utilize 20 automatic core machines, including the Liampi Isocore machine, to create precise and uniform cores. High-quality raw materials are used to ensure the best possible product, while the core assembly process is meticulously performed to guarantee accuracy. The dry sand molding process is employed to create molds, reducing shrinkage and improving product durability. After casting, the aluminum parts are processed through a thermal sand reclamation system, ensuring 100% recycled sand, making the process environmentally friendly and efficient. With 6 furnaces capable of melting up to 7,500 pounds per hour, we ensure a stable and reliable supply of molten metal for casting. The shop also features an automated match plate molding line and 7 green sand production lines with the capacity to produce 2,400 molds per shift. Pneumatic shakeouts and wheelibrators are used for surface finishing, while a 6-axis robotic deburring cell ensures precise cleaning of castings. Additionally, our machine shop processes the cast parts with high accuracy. Strict quality control is maintained throughout the production process, ensuring every product meets the highest standards. Our shipping and receiving department ensures timely delivery to customers. Andrit successfully completed a high-performance headbox overhaul in just 9 days. The process included the complete disassembly of the paper machine headbox, followed by thorough refurbishment to restore optimal functionality. Key components were inspected, cleaned, and repaired to meet high-performance standards. After refurbishment, the headbox was carefully reassembled, ensuring precise alignment and efficiency. Once fully tested and verified, it was prepared for transport, ready for reinstallation. This rapid, yet meticulous overhaul process guarantees improved machine performance, reliability, and extended service life, reinforcing Andritz's expertise in high-quality paper production equipment maintenance. The hot rolling mill at AMNS Calverts is responsible for rolling steel from raw billets into thin steel plates or thick steel bars at high temperatures, making the steel easy to bend and highly flexible while reducing the hardness of the metal. Sheffield Forgemasters, established in 1805, is a renowned steel manufacturer and remains a privately owned company. Specializing in the production of massive castings, they provide high-quality forged components for industries such as energy, defense, and construction. With over 200 years of expertise, Sheffield Forgemasters has built a legacy of innovation and excellence in producing large, complex metal parts. The video offers an in-depth look into the crane manufacturing process at Expert Cranes Factory in Cleveland, Ohio. The process begins with the assembly of large steel structures, where skilled workers thoroughly weld and align various components to form the crane's frame. Once the main structure is assembled, the lifting mechanism, which includes pulleys and cables, is attached, and the system is carefully tested for stability and functionality. Next, the crane is equipped with a rigging system that enables it to raise and lower the hook, and the horizontal beam is moved across various positions. The crane is then fully assembled with the addition of supporting parts, ensuring it can handle heavy-duty lifting tasks. After the assembly is complete, the crane is carefully moved into its final position. It is tested to ensure everything functions properly, with the rigging system working flawlessly to lift and transport heavy materials with ease. Expert Crane ensures each unit is built to high standards for quality, safety, and performance, providing a reliable tool for industries that rely on precise, heavy lifting. The company also customizes cranes to meet specific needs and ensures that each crane will perform at its best, no matter the industry. Overhead welding is carried out on the semi-automatic equipment of the company Lincoln Electric. As shielding gas is used, ARCO2 mix. After being heated at a temperature above 900 degrees Celsius, the vacuum vessel is immediately transferred to the liquid solution for hot forming.